Hai, nama saya Mak Kedai Ismail. Nombor metrik saya A165107.
Hai, nama saya Nasarina binti Nordin. Nombor metrik saya A164481.
Hai, nama saya Muhammad Ridwan Hidayat bin Muhammad, bernombor metrik A166633.
Hai, nama saya Nur Armida Nadiha binti Amin Sabri. Nombor metrik A164383.
Hai, nama saya Nur Najwa binti Muhammad Syahbudin. Nombor metrik A164312.
Okay, Assalamualaikum. This is our project for analytic dan pemeriksaan data. So we choose to observe the volume of hydrogen gas produced in a certain time. Okay, I will do the introduction. The fermentation is a process which is a biomass get converted into product such as alcohol. So the fermentation process is highly sensitive to small change in operating limit that may affect the final product quality. So the aerobic fermentation occur the presence of oxygen, and the anaerobic fermentation occur without oxygen.
Okay, we move to the next part is the objective of the experiment. Regarding to the both fermentation process, we want to study the amount of hydrogen gas released from both types of fermentation process in different time. Okay, next part is the discussion. The first discussion is the amount of hydrogen gas released from the aerobic and anaerobic fermentation process are increased over time. The next one is the result of the experiment shows that the volume of hydrogen gas for anaerobic fermentation is greater than aerobic fermentation. And the last one is the problems during the experiment are the difficulty to collect the hydrogen gas due to more carbon dioxide produced in this process.
Hi, so we go to the methodology part. So we have two methods which are aerobic and also anaerobic. First, we go to aerobic fermentation. Some organisms use an organic molecule as the final electron accepted instead of oxygen. Process that use an organic molecule to regenerate NAD+ from NADH are referred to as fermentation. Then we will continue. Cell metabolize sugar via fermentation in the presence of oxygen and occurs through the repression of normal respiratory metabolism. The phenomenon is very rare and is observed in yeast.
So now for anaerobic fermentation, the first step is the growth culture medium consisted of beef extract 5 gram, pectone 3 gram, and sodium chloride is 5 gram per liter. L-cysteine was put into anaerobic bacterium by 0.5 gram per liter in order to lower the redox potential. And the hydrogen production medium consisted of beef extract 5 gram, pectone 3 gram, sodium chloride 5 gram, FeSO4 0.2 gram, K2HPO4 2 gram, and glucose 20 gram per liter. So for the second step, the medium of producing hydrogen was sterilized at 115 degrees C, then blown by nitrogen gas, and then the pH value was adjusted to 6 to 7 by diluted HCl or NaOH. Keeping the temperature at 57 plus minus 1 degree C, with stirring speed of 200 rotation per minute, the gas volume was measured by gas flow meter and the proportion of hydrogen gas, and the subtract concentration were calculated timely. The third step, the acquired H2 and CO2 mixer composition were analyzed by gas chromatography, which had thermal conductivity detector TCD with column length of 2 meter and inside temperature of 120 degrees C. And the last step, glucose concentration was determined following the phenyl sulfuric acid method, and the hydrogen production rate is defined as the amount of H2 in 1 mole glucose.
So without any further ado, we will move on to our next part, which is the result from our experiment. So from both experiment of anaerobic fermentation and aerobic fermentation, we can see that the data of the volume of hydrogen gas increase within time. So after we obtain the data, we plot the data into graph. So from the graph that we have plotted, we can see that the volume of hydrogen gas produced for both experiments will increase proportionally to our time. So that's all from us. Thank you for watching.
Bangkit.
Okey kot.
Tapi
ni akan
kanan kaki. Kanan.
Okay. That's all from us. Thank you for watching.
Bye.
Bye.